Hello guys, Winston here. Two members of my travel family are getting married and I wanted to make them a little something extra in addition to a more traditional wedding gift. They plan on eventually moving to Colorado, so I decided to make them a topographic carving of their future home state. Now, there are two ways to do this, the easy way and the hard way. The easy way is to find a pre-made STL file that you can carve directly. The hard way is to download a height map where grayscale brightness corresponds to elevation. If you can find a height map that's already cropped to your desired area, great, but you'll most likely have to download satellite data dumps available from organizations like the US Geological Survey, transform the distorted image into your desired projection system like Mercator, trim the image according to the regional boundaries of your choosing, and turn that cropped height map into a machinable file. There are other data sources like Open Topography that give you laser point clouds, or sites like Terrain to STL that automatically generate STL files of rectangular sections of terrain, but no matter what, there's a good amount of post-processing you'll end up doing if you want to isolate custom geographic regions and machine them as topographic carvings. Today, because I'm limited on time, we're going to go through this the easy way. I'm using an STL of Colorado from Noah Lorang, also on Instagram as Elevated Woodworking. He's one of the pioneers of this technique in the maker world and made some basic files of all 50 states available on Thingiverse. These are models that have been run through polygon reduction to make them Fusion 360 friendly and are free to use for non-commercial purposes. I downloaded the Colorado STL file and brought it into my workspace. The first thing to do is to scale down the file to a good working size. Because of the wood I have available, I'm going to try and make my carving about 5 inches wide. This will fit nicely on some scrap walnut I have squirreled away. You can scale the model in the Z-axis independently of X and Y if you want to exaggerate the terrain variations. I opted not to stray very far from the original proportions. Now, this model is sort of a raw STL exported from who knows what program, so the boundaries are a little ragged. To clean up the edges so that my parts cut sides would be clean, I drew up some state borders using lines and arc segments. The way Noah chose his map system meant that the northern and southern borders of the state were curved to reflect how they would be wrapped around a globe. By defining some contours to cut around in a sketch, I could ensure that the walls were trimmed up in a smooth, continuous toolpath. If you were doing this with a more complicated state, you might want to consider importing a vector file of the borders. I extruded this border down so that I could visualize the finished piece in full thickness. With these preparations complete, I went to my CAM workspace. The first step is to define your stock. I opted to define a fixed thickness for my stock material and align it so that my model sat on the bottom of that volume. Operation 1 was facing. That's the most efficient way to remove unnecessary material above your part. I left 8 thou stock to leave though, because any machine deflection will manifest as the end mill being pulled down just a fraction of an inch. The next step is an adaptive clear. I capped the depth of cut so that the toolpath focused on the topographical part and not the base of my model. After this was a 2D contour to cut out the part. All of the toolpaths up to this point used an 1/8 inch end mill for convenience. Sure, using a 1/4 inch cutter would have been faster for facing, but it saved me from having to do a tool change. To wrap everything up, I used a parallel toolpath to smooth out all those delicious 3D contours. For maximum detail, I would be using a 16th inch ball end mill with a step over of 7 thou. As sort of a rule of thumb, I try and keep the step over to about 10% of the end mill diameter or less. This toolpath was constrained to not plunge deeper than necessary. With those operations exported, I headed to the garage. First thing on the agenda was material preparation. It's not a glamorous job, but good carvings come from good stock. I wanted my walnut to be dead flat before starting, so I taped it down in the corners, flattened one side, flipped it over, and flattened the other. With the tape strategically positioned under where I wanted to cut out my part, I could go straight into my toolpaths. Face, adaptive, contour, tool change, parallel. Really straightforward. It was about an hour to run all of these, with the majority of that in the parallel toolpath. After assessing the machine part, I noticed some tool marks on the sides. My parallel toolpath had wrapped over the edge of the part in some places and nibbled away at my walnut where the STL's edges were jagged. I fixed this by running an extra contour toolpath with negative stock to leave. This would cut out the sketched state outline just a little tighter. And now I was finally done machining. I spent a little bit of time sanding away stray wood fibers that hadn't been cleanly shorn by the end mill. Then I removed the part from my wasteboard and worked on figuring out what to do on the backside. My initial thought was to glue a magnet to the thing and brand it, but that felt a little too impersonal. In the end, I concluded that I had to include a message with this piece, and a V carving wouldn't do. A CNC engraving is too sterile for something heartfelt. I knew I had to handwrite something. So I took a few minutes to practice with the cheap pyrography tool that I had, and clumsily scrawled out some best wishes to my friends. It ain't pretty, but it feels right. The last thing to do is to finish this piece with some spray polyurethane. I picked a gloss texture for this so that the contours would have a little bit of shine to catch the light at the right angles. This would help accentuate the contours. I may or may not have also wanted to just be done with this can of spray poly since I use full gloss very rarely. To coat both the front and the back in the same day, I drove screws through some scrap MDF and used them as standoffs. After a day or two, I came back and buffed the edges with some fine grit sandpaper to knock down the grain where it had been raised. I gave it one last coat of polyurethane to reset the surface texture. And that is a completed 3D topographic carving of Colorado. A really simple workflow, but attention to detail is what really makes the end result stand out. In the future, I'd like to try and make my own topographic models that are a little more detailed, but as a quickish project that you can knock out in an afternoon, I'm really happy with how this turned out, and I hope my newlywed friends are too. I want to thank you all very much for watching, and I'll be back with more CNC related content soon.